Good morning. So, we will move on to the last module, which is fire safety aspects. So, any type of fire, we have to choose proper suppression systems and the extinguishing systems for this. So, we will go through this chapter where we will try to analyze the different extinguishing mechanisms and appropriate choices how to make for different types of fire, etc. So, the fire safety aspect, the first important thing is to detect a fire. Okay, the fire detection. So, what you see in a fire is basically there is a heat release. Hot gases rise up due to buoyancy. Soot formation occurs so that the soot particles and hot gases form smoke. And due to the plume carrying this heat, see, for example, we have seen that the convective heat flow rate or the convective heat carried by the plume will be 60 to 80% of the total heat release rate. So, this is the total heat release rate, which is mass burning rate into delta Hc, that is the heat of combustion. So, heat is carried, smoke is present, smoke is at a particular temperature. Okay. So, now in the bottom near to the fire source, we can also see visible flames, and product gases are there. For example, CO2, CO, some unburnt hydrocarbons, I can say unburnt etc. So, we have several things out of which we can detect a fire. Hot gases with soot particles, smoke. So, if you can have some mechanism to detect the smoke, then I can say that there is a fire. Okay, smoke indicates the fire. Okay, if you see a smoke at a long distance, we can easily suspect that there is a fire beneath that. Similarly, the smoke will be hotter, so the heat or temperature can also be used for detecting the fire. Then somehow if you can visualize flame, say for example in some infrared cameras etc., that will tell you the presence of a flame, visible flame, there straight away you can say there is a fire. Okay, if these are all not possible, if you have sensors to sense carbon monoxide, carbon dioxide or unburnt hydrocarbons etc., which are present in the product gases or fire gases, then also you can detect the fire. So, fire sensing is possible by analyzing the presence of smoke, analyzing the temperature or the heat, then seeing whether there is a visible flame or not, and analyzing the constituents of the product gases. Okay. So, based upon whatever method you use to detect this, the cost also will be different. So, for example, CO sensors etc. can be costly, smoke sensors can be cheaper, heat sensors also can be relatively cheaper, okay, and so on. Similarly, you need some say IR cameras or other sophisticated methods to detect a direct flame, but to detect that you will see that the smoke layer can reduce the visibility and so on. So, often this cannot be done easily and so on. So, how to go about this? We will see the mechanism of how to detect this first of all. So, we will go with first heat detectors. How yeah, equipment or an instrument can detect the heat, that means the rate at which heat is transferred from the hot gases to a particular component which can detect it. Okay. So, the heat detectors are used in smaller compartments where a faster growing fire is present. Okay. Heat detectors. The response time of the heat detectors is comparatively higher. That means it takes more time to detect the heat. That is the reason if the fire is going at a faster rate, then the rate of heat transfer also will be higher. This will reduce the response time. But on the other hand, if you have a slow growing fire, then what happens? The rate at which heat is transferred to the component or the heat detector will be at a lower rate. So, the response time will be larger. Now, when I say comparatively higher, I compare it with say smoke detector, etc., or a CO sensor. Now, what is the mechanism through which heat detector works? That is, primarily a part of it or a working substance which is involved in it will respond to the incident heat flux. Okay, that means the heat carried by the plume or a sealing jet will transfer its heat to the heat detector. So, in the form of a heat flux, that is, heat flux is watt per meter square, some heat rate of heat flow per unit area of the detector. So, a part of it, that is some surface, can receive this heat flux, or there will be some working substance that can receive this heat and act upon. The rate at which the heat is coming to surface can be an indication of a location of a fire or maybe the occurrence of a fire. In bimetallic type heat detector, two metals having quite different coefficient of thermal expansion, alpha TH, are used. Okay, now there are two materials. Bimetal means two metal strips. One can be say aluminum, one can be some incur. So what happens? The coefficient of thermal expansion in one may be higher than the other. This can be used. So the expansion undergone by the one can cause deflection in the other, and this can be used to sense how much it has expanded relatively. That can be used to see what is the heat flux. Correlation, we can correlate this. Okay, that is one method. Then we can also say heat detector with a fusible element like a eutectic alloy, which can just melt upon. See, for example, say a wax like material will melt on this. Then when it melts, basically it can trigger an alarm. So the fusible element like a eutectic alloy, which upon receiving the heat flux melts as soon as possible rapidly when it is heated to a particular temperature. So these are the mechanisms. Basically what we are trying to do here is the incident heat flux causes some changes in property of the materials used in the heat detector, and this change in the property of the material will cause some deviations or modifications in the sensor itself, which can trigger the alarm. In the heat detectors, there are other types also. See, we have seen that the bimetallic etc., plus the fusible eutectic alloy etc. Then there one more is rate compensated heat detector. Now it will not get the heat, it will actually measure the rate at which temperature increases. Okay, hot air which is expanding, that will be used for sensing this rate at which temperature increases, and that will be used for sensing the incoming heat flux, and that will be used for triggering the alarm. So there are several methodologies or mechanisms by which the heat can be detected, and once you see that there is a given heat flux which is unusual, then that can be considered as occurrence of a fire and an alarm can be triggered. High heat sensitive cables, liquid based heat detectors are also used. Okay. So, basically there should be a material or component in the heat detector that changes one of its properties upon receiving heat. That is the concept from the hot gas. So, that is the concept used in the heat detectors. So, calibration is required. You have to first subject the heat detector to a known heat flux and see how the material properties etc. change. Based upon that, you will be able to detect the actual fire. The second category is smoke detectors. Here, as I told you, the hot gas has some heat which is transferred to the heat detectors, that is one. But when the smoke comes in, smoke is what? Hot gas plus soot particles or carbonaceous particles. What happens here? You use what is called some optical methods to detect the smoke. Okay, what happens here is there are two methods to sense a smoke. First one is ionization method. Second one is photoelectric based method. When compared to the heat detectors, the smoke detectors have lower response time because and they are faster. So that means in compartments where there are fires with slow growth but it should produce more smoke, that can be detected at a faster rate or within a smaller time when compared to heat detectors. Heat detectors are used when a fast going fire is present. So, you know the application, based upon the application you put heat detectors wherever is required. But in the case of smoke detectors, you should ensure that the smoke formation is good amount of smoke is formed, but the rate of fire growth can be slower because they have lower response time. And also, if there is application where there is a smoke which is already present, then this cannot be used to detect a fire in that environment. So, let us see about how the smoke detectors work. Here, first we consider the ionization smoke detectors. They are basically special radioactive material. They involve that which is used to ionize the air flowing to the detector. Okay. So, a special radioactive material will ionize the air flowing to the material. Ionization, when pure air flows through this detector, the radioactive material will ionize it and we know the output of that. So, how much it has been ionized and so on. However, when the air is containing soot particles or a smoke passes through this detector, then the ionization is affected by the presence of soot particles. That is, when smoke goes through it, then you will see that the ionization is affected. So, how to detect the ionization? Certain quantity of current flows through the detector when it is ionized. Okay, when pure air is sent, a higher quantity of current flows through the circuit or the detector, and you know that is the baseline for a pure air. When smoke passes through it, the amount of current which is passing through this detector will significantly decrease. So, we can now say that there is a smoke which is present and that will detect the smoke. Okay. the decrease of the current flowing to that will indicate the intensity of the smoke. So, when certain concentration of smoke enters the ionization detector, then there will be certain reduction, a threshold reduction in the current flowing to the detector. When that occurs, an alarm can be triggered. Okay, again calibration is required. You have to generate smoke of different intensities and see what is the threshold value which will cause a alarm when the smoke passes through the ionization detectors. So, it is a very well used detector. The second type of smoke detector will be photoelectric detector. This is optical based. A light source and a receiver is used in this. So, for example, there is a light source and there is a receiver, and a flow of gases can be there in between these two. If only air flows to this light source, the receiver will receive some amount of light. Certain intensity of light is going to be received by the receiver. This is receiver, light source. Okay. Now, if smoke flows through in between these two on the line of sight between the source and the detector, then the intensity of the light received by the receiver will reduce because of the soot particles. Soot particles absorbing light, etc. The intensity falling on the receiver will reduce. So, this method is called light obscuration principle. Okay. Now, when air passes through, there is some amount of or intensity of light received by the receiver, that is the baseline. When smoke of different intensities passes through, then the light received, intensity of light received by the receiver reduces, and if the light received by the receiver reduces below a certain intensity, then an alarm can be triggered. Like in the ionization case, when certain concentration of smoke enters, this causes reduction in the current flowing to the detector, which will actually trigger an alarm. Similar wise, here the light received by the receiver, intensity of light received by the receiver, in the presence of smoke passing through the line of sight of these two, will cause the intensity of the light received by the receiver to decrease, and if this decrease is below a certain intensity of light is received, then an alarm can be triggered. This is the basic working principle of the smoke detectors. Smoke detectors are much faster than the light detectors. In another type, photoelectric smoke detector. Okay, so ionization, this photoelectric smoke detector, you can see that there is a light source exactly directed towards the receiver, like what we have shown. It is exactly directed towards the receiver. So, the smoke has to pass through the line of sight. This is line of sight of this source and the receiver. Smoke passing through the line of sight will affect the intensity of the received light. In another type of photoelectric smoke detector, the light source and the receiver are not kept aligned, as in the light obscuration principle based detector. Now, what happens here is the light enters the receiver when smoke particles scatter it. That is it. Or else it will not receive at all. See, for example, there is a light source, smoke goes through this, and the light is scattered basically, and the receiver will be kept somewhere here, not in the line of sight of this. So, the scattered light from the smoke will go to the receiver. If certain intensity of light is received after being scattered by the smoke, here this is smoke, after being scattered by the smoke, then alarm will be triggered. Or else, If there is no smoke, only air is there present in between, then the light will not be scattered at all. This light scattering, the light scattering occurs due to the solid particles or the soot particles which are present in the smoke. The soot particles present in the smoke scatter the light, and some amount of light is directed towards the receiver, which is not kept in line of the light source. So that means there will be no light intensity received by the receiver at all when there is no smoke, but based upon the intensity of smoke which is passing through this, scattering of light occurs by the soot particles present in the smoke, and this smoke scattered light will be received by the receiver. If certain intensity of light is received, then an alarm will be triggered. This is the second method. In the first method, the decrease in the, so they are kept in line. Always there will be some light which is from the source will be received by the receiver, the intensity will be known. But if smoke passes through, the intensity will decrease because of scattering of the light, and only certain amount of light will be received. But by decrease in the intensity is taken for the alarm triggering. But in this case, the amount received due to scattering itself will be taken. So these are two this. So here the photoelectric detectors are more suitable for low intensity smoke or grey smoke, because we can see that the low concentration smoke soot particle present in a grey smoke can be used for scattering the light, and either the first technique where the line of sight is in between the receiver and the source is intact, or it is kept misaligned like this. In both the cases this works. Ionization detector, smoke detector will be more suitable for the dark smoke, because the ionization, the decrease in the current requires more amount of soot particles to be present. So based upon this we can use this. And in the places where high humidity is present, photoelectric detectors are suitable. So for example, in the regions where the air has high humidity, like in say tropical regions like in Chennai etc., photoelectric based detectors can be more suitable. There will be other forms also. Special types of smoke detectors also are available. They are projected beam detector. It is also similar to the light obscuration principle in the first case of the photoelectric what we have seen. And second one is cloud chamber detector. Okay, these are all not commonly used, but for special purposes they are used. Now, main challenge is where to keep the locator, these detectors, then what is the capacity, then how to install it. These are done as per the standards. So how to choose where to keep and how to install it etc. depends upon, or this is done as per the standards. Okay. So we have seen about the heat detectors which are slow in response. They actually measure the heat flux, or basically the heat flux coming into the detector will cause change in the material property, or they can sense the temperature increase and detect it. It may take some time. Some time it takes to get the heat flux, the heat transfer time is required. But in the case of smoke detector, they are having lower response time as compared to the heat detectors. And there are two types, ionization and photoelectric based method. In photoelectric method, there is two methodologies which are followed, and special type of detectors are also used in several applications. So now the third one is flame detectors. Flame detectors, as I told you, the ultraviolet emissions from the flame or infrared emissions from the flame or fire, they are detected in this. Okay, so the flame has several spectrum of radiations. In this, ultraviolet and infrared spectrum also are present. If a detector can visualize a flame, at least focus its attention on a flame and get the intensity of the ultraviolet or infrared emissions, then that can be used to detect the location of the fire or fire itself. These flame detectors have faster response, but they are used in basically industries and fuel handling facilities like in chemical industries and say petroleum industries, etc., where you have a very high fire hazard. They are costlier. Both UV ultraviolet based or infrared based detectors should be positioned so as to view the flame. That means if there is a smoke layer which is obstructing the viewing factor between the sensor and the flame, then it will not work. So, these are kept focused towards the hazardous areas where the probability of getting a flame is higher. Similarly, the IR detector should not be allowed to see the flame sunlight, because it will detect that unnecessarily and say there is a it will trigger a false alarm of a fire. So, the flame detectors are not commonly used in domestic applications. They sense the ultraviolet and infrared emissions from the fire, and they are used in industries or fuel handling facilities which have higher fire hazards, and they are usually of very fast response. But care should be taken to position or locate them so that wherever the flame initiates, this will be able to see the flame and detect the emissions of ultraviolet and the infrared from these fires. So, flame detectors, as I told you, see a fire which gives heat release, heat detectors can be used to detect the heat coming out of the hot gases, or smoke. Smoke detectors basically detect the presence of soot particle laden hot gases. Then the flame detectors has to visualize the flame itself in order to get the emissions, intensity of emissions from ultraviolet and infrared radiations. And finally, gas detectors. As I told you, products of combustion, CO, CO2, H2 also will be there, but it's not used for detection basically. Then unburned hydrocarbons. So, basically, if you have a detector to sense CO and basically CO2, that is enough to see the occurrence of a fire, detect the occurrence of the fire. CO detectors are commonly used in residential apartments nowadays, because CO basically is a very toxic gas, and sensors are available now to detect them accurately. So, using CO sensors, we can see there is a occurrence of fire. So, there are some sensors which can detect the unburned hydrocarbon also, but in industries we can use them. Okay, even oxygen based detectors where basically the oxygen concentration falls below a value also can be used, and so on. But CO and CO2 sensors are most commonly used. Okay, now apart from this detectors, we also can use pressure detector. So, in a compartment basically, due to a fire, pressure can increase. As I told you, the pressure, atmospheric pressure is 101,325 pascals or Newton per meter square. So, now if the pressure in a closed compartment increases to a certain value above this, then that pressure can be detected, the pressure drop or pressure increase can be detected, and the excess pressure can be detected, and this also can be used. Okay, but it is not so commonly used. So, The fire detection is the first and foremost important thing which we do for fire safety aspects. And as I told you, in a fire we have smoke, heat release, visible flames and product gases. So all these aspects can be sensed. Heat sensor is used to detect the heat of the hot gases. Smoke sensor, presence of soot particles and smoke itself can be done. Then flames can be sensed by using the ultraviolet or infrared emissions, detecting that. Then product gases basically can detect the CO2, etc. So these are very important, and we have to know the applications. Heat detectors are used for fast growing fires. Smoke detectors can be used in slow growing fires also. This is most commonly used. Smoke detectors are the most commonly used because basically in domestic applications the fire sources are basically unsaturated hydrocarbons. So they produce lot of smoke. So using smoke detectors are very effective in domestic applications. And the smoke detectors, there are two types, ionization and photoelectric. Photoelectric are most commonly used in several applications. Then flame detectors are used to accurately sense at a faster rate a occurrence of a fire, and this is used in industrial applications where the fire hazard is higher. Finally, the CO based gas detectors are now commonly being used in residential apartments. Apart from that, pressure detectors can also be used, but they are not commonly used nowadays. Okay, so we will stop here and continue in the next class.